My dear student, this is one of the conditional MCQ that belongs to the energy of particle executing a session, or we also say the topic prove the law of conservation of energy using mass spring system. So this is a conditional problem. Problem is that at which displacement vibrational kinetic energy of simple harmonic oscillator becomes equal to its elastic potential energy, or we may say that at which displacement the elastic potential energy of simple harmonic oscillator, or you may say elastic potential energy of mass spring system should be equal to its vibrational kinetic energy. Let us go to solve the problem. First of all, we write the formulas of vibrational kinetic energy and elastic potential energy. We know that elastic potential energy of simple harmonic oscillator or mass spring system is 1 by 2 kx square. Here k is spring constant and x is displacement. Similarly, the formula for kinetic energy vibrational is 1 by 2 k x naught square minus x square. You know that vibrational kinetic energy depends upon the value of this vector. If this vector means x naught square minus x square has the maximum value, then kinetic energy will be maximum. You know that at mean position x is 0, displacement is 0, so the kinetic energy maximum. But here this is not our point of discussion. We have just to solve the MCQ. So come to the condition. Applying condition. Condition is that elastic potential energy is equal to the vibrational kinetic energy, then what should be the displacement? By putting values, 1 by 2 k x square is equal to value of vibrational k, that is 1 by 2 k x naught square minus x square. 1 by 2 k x square same 1 by 2 k x naught square, multiplying this vector, the whole bracket, we will get 1 by 2 k x square. We cannot cancel 1 by 2 k x square on left side and 1 by 2 k x on 1 by 2 k x square on right side, because we have to find the x. So let's simplify the equation. 1 by 2 k x square and this on the right side become 1 by 2 k x square. Here remain 1 by 2 k x naught square. 1 by 2 k x square, 1 by 2 k x square. Half this value become the kx square, or you may take the LCM. LCM is 2 kx square plus kx square is equal to 1 by 2 k x naught square. Kx square is equal to 2 kx square by 2 is equal to 1 by 2 k x naught square. 2 get cancel. Now k on left side, k on right side. get cancelled. Here become x square is equal to x naught square by 2. So when we remove the square on left hand side, we will put the square root on the right hand side, like x is equal to x naught square by 2 whole square root. This square root is over x naught square as well as 1 by 2. Simplifying that, we may write here plus minus x naught square, under root 1 by 2. When we remove square root, or we can cancel this 2, and this, we know that under radical is equal to power 1 by 2. So this is square and this under radical get cancelled. Now we have x is equal to plus minus x naught upon under radical 2. So this is the correct answer of the given conditional MCQ. We know that x naught is amplitude. It is also represented like this. So the option C is correct, and it may also be written like in this way, plus minus, we replace x naught into a naught by under radical 2. So this is the correct option. Such type of MCQs must be solved by using the given condition. So when we are going to start the calculation of these type of MCQs, we must remember the condition in our mind and then start to solve it. Hopefully the calculation will give the correct option. But if we have no any idea how we can solve it, so it will be difficult to get the correct option. So my dear students, it's my advice to you that if you have these type of numericals, you must first find the condition. If there is a condition in the given question, you can apply such condition and then start solve it. Hopefully you will get correct option, you will get correct answer. Wish you all the best.